A2. So if you look at the graph, so you please just look at the graph. So the same representation we have given A1 and A2. The same we are representing in the mathematical form. Okay, so that is the A1 and A2. That is h of omega at omega is equal to omega 1 and A2 is equal to h of omega at omega is equal to omega 2. And also they define the attenuation from the second graph. That is alpha 1 is equal to 1 by A1. As I told you, reciprocal of that. So 1 by A1. So 1 by h of omega at omega is equal to omega 1 and 1 by A2, 1 by h of omega at omega is equal to omega 2. So next, the maximum value of normalized gain is unity. When we consider generally, if you are finding anything, the maximum gain we will assume it as unity. Because we feel that, see, suppose for example, if I am designing any system, we cannot expect that 50 dB, 30 dB like that, isn't it? So what is the maximum expectation we have? Unity. That means we will consider the comparison always will be with respect to unity. So in the same way here, the maximum value of normalized gain is unity. So A1 and A2 must be less than 1 because the maximum gain we are expecting as unity. So the A1 A2 must be less than 1 and alpha 1 alpha 2 must be greater than 1 because they are reciprocals to them. So definitely they are greater than 1. So in this figure A1 is assumed to 1 by root 2 0.707 which was mentioned in the graph. You can just refer to that. And A2 is assumed to 0.1. So what will be the alpha 1 and alpha 2 values from this? Reciprocal of that. So root 2. Alpha 1 is root 2. 1.414 which is greater than 1. Right? So at the same time alpha 2 is 1 by 0.1 which is equal to 10. So which shows that the attenuation values are greater than the gain values. Right? Is it understand? So please take down all this. Don't take the theory part. Just take down from the